Hi all, my name is Vladimir. I'm developer of Linux Studio plugins. It's midnight in Moscow time zone, and you are watching the Nightly Code channel. As far as you remember, we are working on the improvement of the Scarlett device driver for Linux. And today we will continue exploring the behavior of the original Focusrite controller software and check which new features we can implement in our improved driver. First of all, I want to make a short review of changes that I have made for the stereo button switches. I have a smart Git software for managing the Git repositories, and the commit that I have done before the previous stream where I was working on Hello control should be reviewed at this moment. So what have I done before working on the Hello color switching? I have moved the function that is responsible for line output remapping to the top of the source code, since it is used in my additional function that I have additionally made. Then, next change, I have updated the Scarlett 2 mux commit root function. Now it performs the additional notification of mixture controls of mixture software when the change appears. So if there are some changes applied to the mixture driver, then the corresponding control becomes notified, and the mixture software, which is client of the driver, can receive this notification and update the state of controls. Then I have moved the stereo button update function from the controls to the dedicated function, since it is very easy to use this function from two places. And so the Scarlett 2 mute control commit function takes a mixture pointer, mute number, the changed value, the new value to apply, and the number of sequentially placed controls to change. So in this function, we just loop over the desired number of controls and apply the changes for each control and perform the notification of the client software if there is some change applied. And after that, we commit the kind of software configuration updates related to the new state of mutes. And after that, we just return. So this is pretty good function to perform the anatomic change of some control from different places of the driver. So as you see, this is not the atomic change. It requires to change many things, but we can just call this function to apply the changes. And below we have the removed function at this place, which has been moved to the top. We have the simplified Scarlett 2 mute control put function. So this code was moved to the function that I have already showed to you. And what's next? Then the Scarlett 2 mute control put was updated, and all the code which was previously written here also has been moved to the mute control commit, and depending on the stereo switch, we just commit 2 port values or 1 port value. I think this is pretty flexible and can be simply applied to the changes. So next change. Okay, this is the still that function. So the next change. So we also have the stereo mode control path function, and here we just update the stereo switch, and if all is okay, then we just update the stereo mask, and here I have just removed the notification code since it has been moved to the Scarlett 2 MUX commit root. And I have just renamed the variable mask to stereo mask to not become confused about the naming. And the private mute switch, what's mute state for the second stereo channel in the pair. So here I have just added the mute switch control settings for the second stereo switch in the pair if it is present. And what's next? And here we have here's our change, still our changes in this function. The next change, and line out controls also. I have just added the stereo switch variable and moved the declaration of the index to the top. So we don't need an extra local variable since it can be reused from this local variable. So, and some changes related to the remapping of the ports and handling the stereo switch control when initializing the state of the output routing and output muting. So the previous code didn't realize that we have additional fields in the software configuration area, and here we added the corresponding code to properly handle the stereo switch buttons in the initialization. And what's more, and related to the MUX control, we have just moved the mutex log section to the top to not to make confused about the numbers and so on. So for more safety, we have moved the code a bit at the top place related to the mutex logging, and also remove the notification code since it has been moved to the Scarlett 2 MUX commit root. So that's all related to the stereo switching buttons. So you see that many switches are tightly coupled into one thing, and changes related to one button are affecting the changes to some other controls. So I'll close this software at this moment. Yes. And we will continue today on exploring the behavior of the original Focusrite software. And I think probably, I need to turn on the device. Oh, it is already turned on. Okay. And I think we need to learn how the volume control behaves. So is there some information stored in the original software about the volume or not? If not, then we can just go on and work on additional features that are present in the original software. So I think we need to start to connect the device to the virtual machine with Windows. Here it is. We can also launch the command line tool as an administrator. Yes. And switch to USB pickup. Okay, here it is. So I think we need to make the initial configuration of the device. We need to ensure that there are no stereo. Channels in the device. So all channels are in mono mode at this moment. And after that, we probably need to move these sliders and check what is happening. So we have these sliders only for analog outputs, and that's right, since the hardware supports the volume for analog outputs only. And we will do this and check what's happening. So I need to disconnect the device at this moment. Turn off the software Focusrite or original Focusrite control software. And we are ready to start the USB pickup. And as usual, we set the one, and we can name the output pickup file as Scarlett 18i8 analog output volume mono pickup. So here it is. Now we can launch the original Focusrite control software and connect the device to the virtual machine. Okay, here it is. Now we will just do a simple thing. We'll just move the slider to the top, 0 decibels, and move it to the bottom. It is moving slowly, but finally, here it is our limit. So we can do this with the second output. Now with the third. Then with the fourth. With the sixth. With the seventh. Seventh. 1, 2, 3, 4, 5, 6, 7, 8. Sixth, I believe sixth. 1, 2, 3, 4, 5, 6. Yes, seventh one. And the eighth one. Okay, that's pretty enough. We can stop the capturing. And probably at this moment, we just need to turn off the device. Oh, we need to initialize the initial state for the device, and I think we need to do the following thing. We will set this to 0 decibels. We will set this to some value different from 0 decibels. We'll set this to 0 decibels again. And so on. So the second channel, which will be in the stereo pair, we will set to some value other than 0 decibel. So here, 2. It's working pretty slowly. And here, somewhere here. Okay, and then here to 0 decibels, and here, and that's all. So we can disconnect the device and check that our settings have been applied. So we will do this. Okay, then we will launch the Focusrite control again, connect the device and check that our settings have been applied. Oh, oh yes, yes. Non-zero, 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 non-zero. That's all. Okay, now we can just disconnect the device again, launch the USB pickup, and switch from mono to stereo, and then update the volume. So let's launch the USB pickup again. Select one, set the name Scarlett 18i8. Analog output volume stereo. Pickup. And probably that's all. Just launch the Focusrite control, launch the capturing, and connect the device. Okay, that's pretty good. We see that our changes have been read from the device, and now we're ready to switch from mono to stereo. Let's do this. Bam. Huh, interesting. Minus 9 decibels. Seems that the Focusrite control switches the channel with the lowest volume settings. Yes, seems that this is doing so. I think I need to switch this to some volume below this and switch to stereo. Yes, that's it. So the original Focusrite software selects the lowest volume of two channels and sets this volume to the pair of channels when we switch from mono to stereo. We need to take this into account. And the last one. Yes. So that's pretty interesting. So we need just to stop the capturing. And now we're ready to move our capture files to the our main development machine. So here's our C program files, USB pickup, and these two files we take and move to the virtual network share Focusrite. Yes. Okay. Now we're ready to watch what happened there. So just we launch the decode tool and specify the mono settings first. FF Scarlett 898 output analog, output volumes mono pickup. Oh, sorry. Not decode, just run sh. Okay, that's good. And now we're ready to open with the Kate. I also think I need to open my drivers. So file open. Eclipse. OpenSUSE, OpenSUSE 64, customer T, sound, USB, mixture Scarlett, again to see this driver and my version of driver. Clips, backports, debug driver, this. Okay, I think we need to this file on both, and then we also need to line numbers here, and we're ready to open the file that has been produced by the decoding software. So here is the reversing and the clean log. Okay, we'll just remove the lines, and let's see what's happening here. So here is our initial sequence, and what's here? Set data. Yes. What do we see here at this moment? We see that the original software sets the data at the offset 34 in hexadecimal. So I think I need to create new file and move it here. Probably no, there is no possibility to do this. I think I need to select this pen and create new file. Yes, and we see that for the analog, I will write just A1. We set the value to x34 F's offset. Then what's happening then next? We see that there is EC offset and there is also the FD changed to FE, and there is also the BA offset. Oh, sorry. And there is also the BE offset where the value has been changed from CC to CB. Oh, sorry. There was some garbage on my monitor. So here's the full set of changes, and XA 1A6E, I believe this is, what's this? I need to check this. 1A6E. I need to check, I need to look into my notes. And config space. Let's look again. So that's the checksum. That's not that thing that we need to worry about. Yes, that's just the checksum, and the checksum has changed, and that's not the problem. Then we change the volume from FE to FF. I believe this is the case when I was raising the volume. So the volume is FF now. There are no changes except the BC FE to FF. Okay, okay, let's do this. So the next change was the 34 from FE to FF, and 1 BC from FE to FF. And the previous was BE probably. No, BC, FD to FE, and BE from CC to CB. I don't know what's the one BE. I need to look into my notes. Volume settings for each output. I actually I don't know why it was changing the BE when we were in this stereo mode. I don't know. So when we are switching from stereo to mono, we just split the channel. There is no changes applied. Okay. There is no assignment to the output. That's strange. And here too. Okay. What can I say now? We have some change, but I don't know to what it is related at this moment. So it is just change of the BA. So BC and BD are responsible for this volume, and BE is the next channel. I don't know why it has changed from CC to CB. Probably there was some hardware change and it has just committed this change to the software configuration area. Anyway, let's look next. So from FE to FF, then from FF to 0. So the 0 decibels is just the 0. And we see that 1 BC has changed from FF to 0 too. I think I need to remove this 0x prefix. Still we are working hexadecimal addresses. So, and after that, there was also the checksum changed. That's right. And after that, we just perform the series of changes. And for each change, we update the value stored at the 34 offset. And additionally, we update the software configuration area. So that's it. And probably we end up the 34. There are changes. The original driver already has the way how to decode these values. So we don't need to decode these values. Just see that we ended up with the changes at some point, and the last value that we have set is 81 at the offset BC. So the final value is FF81, which is probably the minus 127, I believe. So we'll just take the calc and just set the 127 with an inverse sign and switch to hex, and that's it. So actually the value stored at the offset 34 and 1 BC is just the value in decibels. So that's good. Let's look next. The second channel So we see that we change the value of the second channel. The offset is 36. That's pretty correct. And as usual, we change from FD to FE, and 1C2 is changed from CC to CB. 1C2 offset. Okay. One C2 from CC to CB. And C0 from FD to FE. Oh, I think I know what's happening here. Yes. I believe the address of C0 and previously we have what have we changed? .34 and BC from 0 to FFFF. Is there the first change? No, that's not. I believe here is the first change. 1 BC from FE to FF, from FD to FE. Oh, I was wrong. There 1 BC from FD to FE, and the BE from CC to CB. I probably know what's this. I think the address 1B C 1B8 1BC is responsible for storing the floating point value. From CC to CB. I think I need to look at the address 1BC in the hex dump of the device state. Here, where's it? Here it is at the end. And look at the 1BC. 1BC. Here's the value. And I think this is the exact value of minus 127 in floating point. So we just can check this by writing the simple snippet. So I'll do the following thing. I will just write the test FPU. So write the include STOH in main, return 0, and we will have the include stint h, and write the uint 32 value, and we need to reverse this value since this is the little Indian value. So 0x1a CB FF81, and remove this and do the following thing. Oh, I have to name the file test C, and here we will just do the following thing: float code cast to float and pass the address of the value, and write the print code value %x code %f, and write the int value and the code, and just compile this GCC Oh, now the underscore T postfix missing and launch A out. No, that's not 00, or I'm wrong somewhere. Probably this. I need to look again at the menu. I also can. Where's my here? I think I can just write the f float f value and assign minus 107.0 f and print the uint 32t I code and cast the and print the both. So here there's the just the I code and the failure. So let's do this. Oh, I have made a mistypo. So the actual value is C2FE00. C2FE00. Maybe 126 minus. Just need to check. No. I believe I'm wrong. What's anyway, I need to check the difference between addresses. So the C0 and BC. So we have 4 bytes for the value, and we actually don't know what's the BE. I need to look into my recordings. So volume section for each output stored as array of 4 byte structures. Okay. A byte gain value and some unknown data that I cannot understand at this moment. What's the meaning of this value? So we just need to observe what the values are written there. So actually for the whole device, the values are CB1A. I don't understand what's the CB1A. I think I need to look into the hex editor and to see what it does give me. So I just need to launch the calc and try to convert the values. Well, so decimal 1A sorry, hexadecimal 1A is 26 and CB is 203. And what if I add 26 then 229? That's nothing interesting. And what if I set the 1ACB in hex 6859? I don't have a clean understanding what's there at this moment. Probably it can be responsible for the second audio channel in the pair, but I actually don't know at this moment. So there are 2 bytes responsible for the same volume settings here, and the second 2 bytes are not known at this moment what is responsible for. I think we need to look the stereo settings, and probably we will find out what's happening there. So let's look into how the other settings are affected by the software configuration and the volume changes. So we have the 36 offset, and the changes are the same probably from CC to CB. Okay. A3, the offset is 36. The second offset is 1C0. Oh, that's A2. So we need to watch the next one. This is A2 probably. Yes, this is A2. And next we see the A3, and the offset is 40. Since the ports have some renumbering, the offset is 40. So, and what is in the user software configuration area, we have 1C6 change. So this is the next 1C4. This is the next value after the A2. So the hardware numbers are jumping and the software numbers are not jumping. So 40 and 1C4. Okay, then the A4. 44. 44 and 1C8 probably. Yes, 1C8. So I think we can stop at this moment, since this is true for all other channels. The only thing we need to know how the second pair of bytes in the configuration area has been affected by the volume changes. Maybe this is somewhere related to the panning controls. Is there some panning? I don't see it. I don't see any panning controls here. If you see them, then please tell it to me or show this. I see only the mute buttons. Okay, I think we need to learn to study the second one scenario when we just work with the stereo outputs. We first switch the mono outputs to stereo and then adjust the volume settings. So I'll just call the second decode function, run sh, and enter the stereo pickup. And the file should be reloaded. Yes. And we need to look what's happening here. So this is still initialization sequence. I don't need to look at this moment. And here is our first switch from the stereo to mono. From mono to stereo. And as we see, the 182, they have set the 34 value to the from the 0000 to the F7FF. Then the second value has been applied to F7FF, but there is no necessity since the value didn't change. And after that, the value at one before is set from 0 to 3, and that's the stereo flag as far as I remember. One before, yes, mono to stereo switch output, yes, that's correct. Back to my Kate. And one BC is changed from 0 to F7FF. That's pretty correct too. And the 1C2 offset is changed from CF to CB. And why it is CF? Hmm. That's pretty interesting. 1C2 from CC to CB, and where it is, and where else it has been changed from CB to CF. I think I need to launch the decoding of the previous scenario again and look how this has been changed. So let's go back, reload the settings, and look again. From CD to CC, where this is initialization code. CD. Is there some counter, I believe, 1C2? And when we change the value, the counter is decreased. CC to CB, CD to CC, CC to CB, CD to CC, CC to CB, and we have changed CF to CB. And let's look at the next scenario. Kate. Yeah. From CD to CF. From CD, C, D, from CD to CF. The B2 was set. I think I need to look again. Change flag, probably. Hmm. I think this can be the flag that is responsible for the hardware control. So we can adjust the hardware control of the output. And if we set the hardware control of the output, probably uh, this value will be set to 1 or not. I don't know at this moment what does this flag mean, but I think the B2 is responsible for something. I need to write B2. Oh, okay. Let's look further. So we have changed from CF to CB. So we have done this transformation. And let's look next. So here's the 34 offset. Then we have the 40 offset. This means that we are touching the A3 and the 4 channels. 1C4, yes, is changed from 00CF to D9FFCB. This is pretty right, since the D9FF is responsible for, and we also see that the 1CA is changed too, from CD to CB. Was there the change previously? One BC, just one BC, and one C2, just one C2. Okay. 1C4 and 1CA. I don't know why 1CA is affected. Oh, I know. The 1CA 1C4 ends with the 1C8. So 1C4, 1C8, the second one, A4. And what's with 1CA? Why it is changed from CD to CB? I don't know. I actually don't know why it's changing. Probably it should be somewhere. Oh, 1C8. That's right. 1C8 is the second channel, and the value is changed from CD to CB. That's right. So the A3, A4 changes were made. The 1C4 0000 to D9FF, 1C6 the CF to CB, and the 1CA CD to CB. I actually don't know what's the CB value. Um, okay, I think we need to look what's happening then. What's next? Then we have to adjust the volume settings for the sixth output. That's right. And after that, we have switched the pair of outputs from stereo to mono. And this is. So we have set the value. So there was the set data sent to the device that changes the volume for the 38. But the volume was the same, and the volume of the second output was changed to uh, some value. Is that right? Oh yes, we have set the value lower than the value in the second port, I believe, or not. Oh, we have just lowered the value and checked that the actual value was applied to the lowest volume. So, and we see that there is CD to CB change and D. So, this is pretty understandable what's happened then there. After that, just the same thing. Yes. I don't know what these values mean. I think we need to make the additional capture when we switch from stereo to mono back. But I believe there were some changes captured previously. I think, okay, I think we will leave these values at this moment. We won't touch them. We will just add the handling of the volume settings and store these values into the software configuration area. So we need to add the corresponding fields to the driver. Probably in the software configuration area it is already present. So we need to add the proper handling of these values. And we need to first update the mono to stereo switching. And the second, we need to update the volume settings of the device. So I think I need to make a short pause within 2 or 3 minutes and I'll get back. So please stand by. So I'm back, and we will work on the driver code now. So um, here's our driver code. I think I need to move it to the first place. And first of all, we need to look how the stereo button is applied. I think this is the simplest way we can do this moment. We'll need to look at the structure, at the data structure, and ensure that there is the volume setting control custom mix. Out mux. Okay, Scarlett software config volume, and here it is LE16 volume, and the changed value and some flags. All right. What we will do at this moment, we will add the stereo button switch. Stereo mode control get and stereo mode control put. How do we need to handle this at this moment? We need to ensure if the value has been set. Then we just update the stereo mask. And update the routing. And moreover, we need to update the volume of the device. So we need to read the volume settings. So there are U16 we need to read the volume settings, and I don't think that should be U16, but it should be signed 16 volume settings. And here we need to read them properly. I need to look at the driver and look how these volume settings are stored. So Scarlett 2 device info, and here they have volume. And this is U8 volume. I need to look how the volume is adjusted. Update volume. Update volumes. This is the code that has been that reads the state of the volume settings from the hardware control. Private demute. Private demute. Get volume status. Actually, we have the volume status structure, and in the volume status structure, we read this master volume plus Scarlett 2 volume bias. And what's the Scarlett 2 volume bias? Oh, sorry. Scarlett 2 volume bias is 127. So, in fact, we do the following. We store the volume read from the volume status register uh, or the area or the memory cell of the device, and add the offset, which is the Scarlett 2 volume bias. So we have the unsigned master volume settings here. And when we store the value, volume CTL part, what does this? It just subtracts the volume bias from the value, and that's all. So what do we need to do? We need to do the following. We need to compare two values and select the value with the lowest value and update the second one. So we have I think I need to move this code to the dedicated function, and this will be more proper, I think. Yes. So this code should be moved to the dedicated function that will control the volume. So where are the additional functions that I create? Commit software config, dump config, USB get config save work, USB gets. Yes, this is Scarlett 2 mux commit root, Scarlett 2 mute control commit, and probably I think I can add the function here, and Scarlett 2 volume static int Scarlett 2 set volume, and pass the mixture as an argument. Pass the volume, pass the index, volume, and probably count. Okay, and here what we will do. We need to update the software config, and we need to update the hardware settings of the device. So we just need the private and card here. And here we need to do the following thing. We just read the previous value. We just perform the loop, and we have the counter. And we do the following thing for I from 0 to count. We just read the old value, read the value. So here is the int count. And we need to check if the old value differs from it doesn't differ from the value, we just go to the next loop. So actually we do the following. We just compare the if private volume at the specified index is equal to the volume, then we just continue the cycle, the loop to the next iteration. Just this. So we actually don't need the old value and the value at all. So then we just need to store the new value. That's right. And update the volume and commit to the device. And we commit the value we need to the error variable. We assign the 0 to the error. So we just do perform the Scarlett to USB set config. And if error is less than 0, then we just force the exit from the loop. So private volume at the specified index is assigned to the new value, and we just perform the Scarlett to USB set config with the specified index of the control and set the corresponding value volume minus Scarlett to volume bias. And after that, we just increase the number of updates. As we did here. Yes, updated. The number of updated. We just increase the value. And after that, we can submit the change to the software configuration area. The one problem is that the index here, I think I need to go back to the set volume control. Here's the remapping probably. Yes, we have the remapping here. And we need to apply this remapping for the index. So we need to do the remapping. So that is, and we need to use the remapping for the hardware control. Yes. I think I need to get rid of the remapping control by just naming the ports. I think I need to do some refactoring after we will end up with the volume control and routing of the outputs. I actually don't like the remapping is implemented in this driver at this moment. I always become confused of numbering of the outputs of the software config and the outputs that actually are used for the device hardware configuration. And I need to make them matching one to another, make them exactly matching one to another. And this can be done by what? We just have an index which is responsible for the software configuration, and we have an port name that's properly remapped. I think I need to think on this, and probably I will do this in the next stream or as a homework. Uh, since there is a lot of job to do and tests, this probably won't be covered by one stream, so I probably will do this offline. Yes. So anyway, now we have the remapped. So I need to add the corresponding comment. And after we have did this, we can store the new value to the software configuration area. So we just need to the value U32 U16 value U16 code. I think the Scarlett USB set config uses the int as a value. Yes. Okay. This uses. I think I can just do the following thing. I need just to set the int new volume. Write this value. I think I need to hardware volume. Call this hardware volume. Hardware volume. Volume minus this. And if all is okay, then we just commit this to software config. If we have the software config, then we commit these changes to the software config. We write the private software config. Where's the data structure? Here it is. How it's called. Go to device info. Okay, software config, and we have the volume settings. Add the index, volume, CPU to LE16, and here we pass the U16 hardware volume. Probably this will work. So we have updated the volume settings, and after all, we just need to check if the software configuration has been changed. Then we will commit this software config. And we need to pass the mixture as an argument, the address, and the number of updated elements. So count multiplied by the size of this structure. So I will just split the line and pass the size of this structure. And we also need to check that there is no error. What's here? Oh, we can just leave from the function at all, so we will return error. And here we just write the value to error. And we will return the number of updated elements if the error we will return the number of updated elements if all is completed successfully. So now we just need to refactor the software volume.ctl path and pass the correct value here. So we write the index is an element control and just pass the error if error greater than or equal to 0, then we set the error to 1 and call the Scarlett to set output volume. I think I need to write the output volume. Yes. Scarlett to set output volume, pass the mixture, pass the index, pass the volume, so I will rename this. And pass the number of elements. This is 1 at this moment. And that's all. So we need to add the reaction to the stereo switch in this code. So we have the output switch to stereo. We need to handle the both changes. So I need to look into the routing settings or not. I think I need to look to the mute settings. I need to add the bookmark to here. Add the bookmark to here. And go to root setting to the mute settings. And there is index stereo group. So we need the stereo group here. And we will assign this update single volume or pair of volumes depending on stereo settings. Stereo group value, we have read the value volume. We will log the changes, of course. So we'll log the Scarlett to volume control put, index specified, stereo group specified, value specified. And after that, we just watch. What should we do? We read the stereo settings, and depending on the stereo settings, we just launch the update of the stereo pair or the of the mono pair. So actually we pass the mixture index and reset bit. That's true. Volume and value are 2. The number of ports is 2. We just update the pair of ports. The only thing I think we need to I need to return back the volume to val. So here is the val, here is the val, here is the val. Is there a volume? No. All right. So now we have updated the volume control put depending on the stereo of the settings of the stereo switch. That's pretty cool. Now I need to do the next thing. I need to probably to check how it will work. We will switch from mono to stereo and adjust some volume and see that the volume will be applied. So let's do this. So I need probably to recompile the driver. Oh, there are errors. Unused variable warning, unused volume settings. I think I can remove them at this moment. 2388 line. Okay. So I don't need the card at this moment. Oh, I need the card at this moment. I need to send a notification. Yes, I have forgotten about this. Notify clients about the change and increment number of updated elements. I just need to software configuration. And here also I need to write the comment that we need to notify clients about change and increment the number of the updates. And of course, we will just do the following. We'll private I believe this is volume CTLs. Vol CTLs. And here I just need to pass index or remapped. I believe index. Oh, I think I can get rid of the remapped value. I can just pass here the index, not index. I think I need to rename this. I need to output. Yes, I will call this output. I will rename this to index and use output here and remapped to index. I index And here we update the output plus I, and here we use output plus I. This is pretty fair. All right, and that's good. And we have also the 2678 line. We don't need the unlock the label. I have forgotten the number of the line. 20 72. Okay, I believe that's it. We don't need the unlock label, and we have the problem, the warning there. Oh, we have we were required to put the colons instead of the semicolon in the Turner operator. So let's look further. And we have the volume settings at the line 32, 38. We just need to remove this at this moment. Volume settings. Yes. Now we're ready to compile. Make G8. Oh. 2415. Okay. What have I missed? Oh, I have forgotten the and the updated variable should be initialized with 0, and that seems to be good. And 2425 control reaches end of non-void function. 2425. Okay, so we have return there. Here, what's the problem? I just need to relaunch the compilation. Oh, that compiles now pretty well. We're waiting until the kernel module becomes built. Pretty long to wait. I can just do the mod probe. The kernel module. Just for the one reason to just find the history of the replacing the driver and just applying this. I don't see any changes in the log. That's strange. Anyway, that seems that we have built the module and we can just connect the device and test it for changes. So I will just disconnect the device from the virtual machine with Windows and connect the device to the virtual machine with Linux. So let's see what will happen. And where's my driver? Maybe I need to call the also mixture. Oh, here's the driver, but I don't see any dmask. What's happening? Oh, I see what's happening. We have launched the another driver, another kernel, 5.3.18. So I need to reboot the virtual machine. And update the grab configuration. All right. And boot grab configuration. I have updated the software on the virtual machine, and it seems that it has rewritten the grab configuration for the virtual machine. And where's the boot menu grab config? Yes. And I think I need to replace the where's my RT kernel? I don't see my RT kernel in the grab config installed at all. That's pretty strange. So I need to install the kernel. I will launch the make modules install, and after that I will launch the make install it, and probably it will update the grab config and deploy the new kernel to the grab config. And after that I will be possible to reboot the new kernel. So now I will just disconnect the kernel, the driver, the device from the Linux machine. And install the kernel and relaunch the virtual machine. That's pretty weird. That's pretty weird. I didn't ever seen previously that the new version of kernel is removed from the grab, or probably I need to make the symbolic link in the user source. Well, I believe it is made there. I need to check. I think the problem is that the symbolic link is missing in the user src directory. I need to check this. So this is the wrong machine to. Oh, I'm not. I'm not connected to the. Yes. Ha. That seems that I was wrong. I was just not connected to the virtual machine. And that seems that this is the case. But I still need to wait until the module installation will be completed. After that, I can just connect the device back to the virtual machine and look for the logs. Yes, we don't have the device at this moment. Okay, it has completed, and now we can launch the driver and see what's happening here. So let's do this. Yes, we see that the device has been connected. Okay, that's good. And now we're ready to just select the device, switch to all controls, I think, and we need to find the stereo switch from the line out for the analog outputs and see what will happen. Oh, I think I need to check at the first time. I don't remember what the mode is set to the stereo outputs, to the outputs at all at this moment. So this moment we are set to the stereo. Yes, we are set to the stereo. I think we can reset the settings in the original software and get back. So just we will disconnect the device, connect it to the Windows machine, relaunch the Focusrite software configuration control center, and we will switch alt from stereo to mono. And go back. So we have updated the device configuration. We will disconnect the device and connect it back to the Linux machine. That's good. And we are ready to select the device, and we see that the stereo settings have been reset. This is as we have expected. SPDIF is muted at this moment. Probably. I don't remember. Was it muted or not? Anyway, we need to look at the volume settings at this moment. So here it is. Line 1, line 2, line 3 and line 4, line 5, line 6, line 7, line 8. And I think I can just launch the second also mixture to not to scroll the device and go to volume settings and go to stereo and mono switches. So here's the stereo switch for the analog output 1 and 2. So we can update the settings of one of the analog outputs. I believe this 0 decibels, and this is minus 5 decibels. Okay. And when we will switch from the mono to stereo, adjusting one of the settings will affect the second one. So we will unmute this and probably will update this video. No, that didn't change. What's happening? Let's see. Scarlett to volume control put index 0, stereo group 0, value 119. Okay. Scarlett to USB set config. This is pretty good. Scarlett to USB set. Okay. And we apply two settings. We do the commit software config. We set 8 bytes. And that's all, but we don't see any changes applied to the... Oh, we have the set config, yes. We applied 2 bytes to the offset 34. And that's only. What did we miss? Ah, I think I know what we have missed. The mistake is here. We need to do the output plus I. And after that, all will work. And here we don't need the index, we need the output. So the index is used only here, and the output is used only here. Yes, and we need to recompile the driver and check again that the new changes will be applied. The mistake was that was just a silly mistake. So we're rating. It's ready now. Now we. Oh, we need to disconnect the device. That's it. Then we need to reconnect the device. Yes, that is good. Then we select the device. And as we remember, the device is set to stereo, and changing the line 01 will affect the line 02. Yes, that's good. So if we change one of the settings, the second settings is also changed. That's good. And if we disable the stereo settings, then we can change them independently. Yes, that's good. And we set, when we set the change, then there is nothing changed at this moment, but if we trigger the change of one of them, then the second is applied too. So the only thing we need to do at this moment is to add proper handling of the stereo switch button to select uh, the value with the lower volume and apply this value to the volume settings. So this can be done in our driver. In the Scarlett 2 mute control switch, mute CTL put here. So mute CTL commit, there is a change, and we get the mute CTL commit. Probably we need to add the bookmark to this. And here we just need oh, we don't need the mute control. Oh, we need the stereo CTL put. Yes, stereo mode CTL put here. And as we see, there is not pretty non-trivial logic for this. I think this can be simplified, but not at this moment. We'll just add the corresponding code that will update the volume here. So we have the output number and we have the index. And we probably have the stereo group. Where's the stereo group? What's the index? Oh, yes. The index is actually the number of the stereo groups, since we have one switch per two outputs. And here we just need to read two values, two volume values, and switch the lowest value of two. So we will just use the U8 output volume. And here we will just do the following thing. We will first adjust the volume and then adjust the routing if it is required to be adjusted. So update the volume settings to the lowest one of two. And here we just update the output volume. We will assign the value private volume. The first index is output number, and the second is output number plus 1. And we need to select the minimum value from these both. And after that, we just need to apply this volume R. Here we will scroll to the volume set output and copy the settings from this. And also we need to ensure that the output number is the line output. And if it is true, then we need just update the volume for this. For analog outputs. Yes. So we have the output volume, output number 1, and output number 2. Yes. And we have the index, which is actually the index shifted by 1. We set this to the output volume. And we update two ports. And if error is less than 0, then we just leave the function. So that's it. So if we have the stereo mode set, then we read the value from the both inputs and adjust the lowest volume of 2. And I think this is pretty nice. So we just need to check that the control is properly handled in this moment. So we need to recompile the driver and check. Oh. Scarlett to data has no member named volume. I need to look again. Probably volumes. Oh, just vol. All right, then we will just update the vol field. All right. That's it. Oh, the module isn't used. Then we just disconnect the device. Reinstall the driver, and we're ready to validate the work with our driver now. Yes, the device has been initialized. Here's our dump. Here are our volume settings, CB1A, CB1A, and so on. And here we will just select the device and try to change. I need to ensure that the volume is set to stereo. We will switch to mono first. Then we will adjust the volume of some output, and we will switch to stereo. Yes, that works. And again, we will need to check. We'll need to check the second output in the pair. We will raise the value for it and switch from mono to stereo back. Yes, that's working, and that's working this way, and that seems to be good. We need to check the second output, line 3 and 4. This is analog output. 3 and 4. I will just raise the value and check. Yes, that's working. And that's working pretty well. Yes. That's nice. The only thing left is that we need to to update the volume control. That's interesting case. I think how we can check this. I think we can do a small but interesting thing. We will set in this software, in the original Focusrite software control, the value, some value. Then we will lower the hardware settings for the hardware device, and then we will check how it will affect the software configuration, the original Focusrite software. So I will just disconnect the device from here, connect the device to here. So we will just probably raise the value here and lower the value here. That's pretty not. So we'll disconnect device. We will recompile the driver with disabled software configuration commit. I need to go to the set output volume and disable this code just for testing. And I will recompile the driver. Probably it will ship the warning. Or it doesn't ship the warning. Okay. I will start the device in the Linux driver. Then I will just update the volume and see how it will affect the original Focusrite software. Will it read the hardware volume settings, or will it read the software volume settings from the software configuration area? So let's do this. So we will install the driver, connect the device. And we will update the settings. So we see, all right, we will lower the volume here and raise the volume here. That's pretty nice. So we see that when we change the volume, there is no software configuration area updated. Yes. And now we can disconnect the device and connect it back to the software or Focusrite control software. And see what will happen. So I will just close the software. Launch it again and watch what will happen. As you remember, the first pair of outputs was with a high gain and the second with a low gain. As you see, the original software configuration, the original Focusrite software reads the software configuration area and applies the gain stored there to the hardware gain. So we need to initialize the volume settings from the software configuration area and apply these settings to the device. Pretty good. Okay, let's do this. So we need to uncomment the changes in our driver. And we need to go to the initialization code, add line out controls, and here's the volume somewhere. Yes. Here's the volume fader. And here we need to properly initialize this value. If we have the software configuration, I think I need to move this to the dedicated cycle, to the dedicated loop. Port mapping. This is related to the mute switches and related to the stereo mode switches. What's the port mapping? Software port mapping. Okay. No, this is the mapping of the hardware ports to the software ports. Yes. Uh, Here we need to add an additional loop, I think, or split this loop. I think I need to split this loop. Yes. And here I need to replace at volume faders. I add output volume faders. So here I need to check that we have the software configuration area. And if we have the software configuration area, we need to apply the volume settings. And also we need to move this after we have the stereo switches in the initialized because we need to take into account the stereo settings probably. So we need to take the volume. We need to apply the stereo switch as index shifted by 1 to right. And we need to apply the volume as uh, as uh, hmm, how to deal with this. I need to look at the implementation of the. Oh, that's just LE16. I don't know the sign of the value. So here we need to read two volumes and decide which one we will set. I think I need to use an array. So if the stereo switch is set to 1, I just can check this. So else match it. Then so that's see that the volumes 0 will be set to private software config volumes I and the volume, and all is converted from the LE to CPU and plus BIOS. And the second volume the same. And we need the number of the stereo index. Yes, we need the stereo index as an index shifted by 1. So here we use the stereo index. And here we need to compute the right volumes, and finally compute the volume as the minimum of 2. And here just take the first one. And here we need don't need the I, we need the stereo index. Oh, here's the remapping, and here we stereo index, we shift the I by 1, and here we use the output index. I believe we can use output index. Or yes, And here we use the output index +1, +0, and +1. That's pretty weird. And actually we don't need the volumes, or we need to have the volumes. And here we can call the air. And here after all they can call the same as we do for the mono to stereo switch. So we go to the function volume mute set output volume stereo mode city output, and here we just commit the right value for this. And here we need to add the check that there is a control present, and we don't have the control present, we don't need to notify. So here's the function Scarlett to set output volume, and if the control present, then we notify. And this should be true for the previous one. Function. And maybe for the and for this too. Why do we do this? The main problem is that at the initialization stage, we don't have the controls bound to the mixer, and here we just create the control. And not to make the driver crash, we just need to take the proper value. Yes, that is the initialization of the properties outside of creating controls can give more safe code, but I don't think that we can care about this at this moment. So I can change the code and pass the minimum function just here, and that will work. And here. Also, we don't need to update one or two values. We just need to update one value, so that's good. I just need to pass one single value, and just select the minimum of two values. Okay, and here I just need to compute the volume with the index 0. So that's probably all, except that I need to pass the I here, not the index. And check the error. So I think this is pretty good. And we can see that the driver at this moment initializes with the hardware settings. We can look at this by just connecting the device and see what will it give to us. We have left on, have, okay, let's see. Yes. Oh, the driver has reset, the original Focusrite driver has reset the value. So we don't commit the value at this moment. So we just need to lower and to raise the value. And if we disconnect the device, then we will see that the value won't be changed. So let's do this. So the driver will initialize with these values. So here's the initialization stage for the driver. Yes, it has been initialized and the state is yes. And after we deploy the new version of driver, then our levels should be changed. Yes. So let's do this. I really need to compile the driver and check. I hope it won't crash. Oh. Oh, sorry. That's my mistake. We need to use the LE16 to CPU. The output index is what? No. Yes, the stereo index. And what's the index? Where do we use the index? We don't use the index at all. Seriously? Where do we use the index? Oh, just here. All right, that's fine. We don't need the index at all. That's better. And there isn't. Now let's check. Oh, volumes. volume. Yeah, yes, that's right. Just wrong name of the field of the structure. It compiles. Well, now we can now we can disconnect the device, redeploy the driver, and check. Yes, that's good. Yes, we have did this, and now we are ready to connect the device and check what will happen. Yes, all seems to be initialized, and after that we have exited the also mixture. Yes, yes, the right settings now have been applied. That's good. What do what do we have at this moment? We have the software volume settings set to the. We have the software volume settings applied to the software configuration and to the hardware controls. The only thing left is that we need to see how the hardware volume control is applied to the signal. I think with this, I think we will do this in the next stream. We'll look how the hardware control knob affects the software and hardware volume, and how it is also applied to the software configuration area, and how the driver should handle all of this stuff. And probably there will be mute and dim buttons that also need to control all this stuff, and so on. So I believe this is all at this time, except that I need to commit my changes to the Git and review all the job that I have done today. So I'll just open the new tab, connect to the virtual machine. Oh, I don't need the super user account. I just need to go to homework, change the directory to the GitHub version of the driver, and change the directory to my current version of the driver. The driver grows. The size of the driver is about 159 kilobytes. And let's make the git diff to review our changes. So we have corrected the behavior of the notification. That's good. We have added the function that adjusts the output volume. That's good too. We have the meter levels update. Yes, that's good too. meter levels. Volume control put. Oh, that's okay. That's the volume control put, yes, function. Okay, so we have updated the volume control put. Just simplify the function and call the helper function to update the settings of the output volume. We have introduced changes to the Scarlett to stereo mode control put to update the stereo mode and control the volume of the output. We have moved the volume control creation code to the bottom after the stereo control initialization, and added the handling of the software configuration to adjust the actual volume of the driver, actual volume of the output. And that seems that's all today. That's all today. So we need to do git add dot git status. That's good. Now we just perform the git commit, with the message edit software configuration support of the volume controls for the analog outputs. Added software configuration support of the volume controls for the analog outputs. Yes, that's right. And probably git push. That's all. So we have the changes pushed to the git, and thank you for watching. If you have any questions, please ask me. You can write the feedback or email me or join the next stream and ask additional questions. I hope you have enjoyed this video. You can send the donations that help me to purchase the new device and support the Linux Studio plugins project. Please subscribe, set the thumbs up, click the ring, and recommend this channel to your friends that are interested in the programming. So I think I'm ready to say goodbye for this moment and for today, and see you soon on the next stream on the next week. So bye bye.